Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have a divided by 2 and its whole exponent is 6 is equals to 2 to the power of 6, and we solve this problem for all the values of 6. So here we see that this equation has exponent 6, so it means that this equation has 6 roots. We need to find all that roots of this equation. So in the first step, we break this exponent and we apply this separately on both of these two values, and it will becomes a to the power of 6 divided by 2 to the power of 6 is equals to 2 to the power of 6. In the next step, we move 2 to the power of 6 to the right hand side, and it will becomes a to the power of 6 equals to 2 to the power of 6 multiplied by 2 to the power of 6. So here we combine the exponents into the right hand side, and when we combine the exponent it will becomes 2 multiplied by 2 and its whole exponent is 6, and this implies that we get a to the power of 6 equals to, this is 2 times 2 becomes 4 to the power of 6. And in the next step, we move 4 to the power of 6 from right hand side to the left hand side, and it will becomes a to the power of 6 minus 4 to the power of 6, and this whole equation is equals to 0. And here we rewrite this equation as into the form of squares, and it will we write this 6 as a cubed and its whole square, minus we write this 4 to the power of 6 as 4 cubed and its whole square, and this equation is equals to 0. Here we use the nice algebraic formula, and according to this we write it as a cubed minus 4 cubed into a cubed plus 4 cubed, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write a cubed minus 4 cubed equals to 0, and the second case is we write a cubed plus 4 cubed, and this whole equation is equals to 0. So we call this is our equation number 1 and this is our equation number 2. So we need to focus on equation number 1, and in equation number 1 we use here this nice formula. If we have x cubed minus y cubed equals to x minus y times of x square plus xy plus y square. So we apply this formula on equation number 1, and equation number 1 is implies that after applying this formula it will be written as a minus 4 times of a square plus a times 4 plus 4 square, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write a minus 4 equals to 0, and the second case is we write a square plus 4a plus this 4 square becomes 16, and this whole equation is equals to 0. From here, we easily get the value of a is equals to 4. This is the first root of the given equation. And now here, in order to find the other roots, we need to solve this quadratic equation. And here we apply the quadratic formula to solve this quadratic equation. So for this, first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 4, and c equals to 16. So we state the quadratic formula as a equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So we substitute all the values of a, b and c in this formula, and we obtain a equals to, this is minus b, the value of b is minus 4 becomes minus 4 plus minus square root of b square. So b is 4 square minus 4 times of a is 1, and c is 16, and it is divided by 2 times of a, and here our a is equals to 1. And now in the next step we need more simplifications, and it will becomes here minus 4 plus minus square root of, this is 4 square, and 4 square becomes 16 minus 4 times of 16, and it is divided by 2 times of 1 is equals to 2. And now in the next step we need more simplifications, and it will be written as a is equals to minus 4 plus minus, here you see that inside the square root sign we have 16 with the common term, and after taking common 16 we get the remaining values are 1 minus 4, and it is divided by 2. And further in the next step we have our a is equals to minus 4 plus minus, here you see that square root of 16 becomes here 4 times of square root of 1 minus 4 becomes minus 3, and it is divided by 2. So here we need to break this fraction and we write it as minus 4 divided by 2 plus minus 4 times of, here we know that negative sign appears inside the square root sign, it will becomes here iota, and it is divided by 2. And now here in the next step we have our a is equals to, this is 2 times 2 becomes 4, and we get minus 2 plus minus, this is also 2 times 2 becomes 4, and we get 2 times of square root of 3 into iota. So these are the other two complex roots of the given equation. And here we get the first real root, it is a equals to 4. So these are the three roots of the given equation which we get here from first method, from first case. And now here we need to move towards our second equation. So in second equation we copy down here, it is a cubed plus 4 cubed equals to 0. So in the same pattern which we can adopt in equation number 1, we again apply the cubic formula on here, and you know about that, if we have x cubed plus y cubed equals to x plus y times of x square plus xy plus y square. Sorry, this is minus xy in the positive formula. So when we apply this cubic formula on the above equation, so that our above equation is written as, first you have a plus 4 times of a square minus a times of 4 plus 4 square, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write a plus 4 equals to 0, and the second case is we write a square minus 4a plus this 4 square becomes 16, and this whole equation is equals to 0. From here, we easily get the value of a is equals to minus 4. So this is the first root which we get here from second equation. And here we again apply the quadratic formula to find the other roots. So we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to minus 4, and c equals to 16. And we state the quadratic formula as a is equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. This is our quadratic formula, and here we substitute all the values of a, b, and c. So here we adopt the same steps which we can do in the first equation. So here I can just skip some steps, or we direct do the calculations. Okay, I hope so you understand all of these steps. So when you substitution all of these values here, it will becomes 4 plus minus square root of, the value b is minus 4, and minus 4 square becomes 16 minus 4 times of a is 1 and c is 16, and it is divided by 2 times of a, and here our a is equals to 1. Further, in the next step we have our a is equals to 4 plus minus square root of, here we need to take common 16, and we get the remaining values are 1 minus 4, and it is divided by 2 times of 1 is equals to 2. And further, in the next step we have a is equals to 4 plus minus, we know about that square root of 16 becomes 4, and this will becomes 1 minus 4 becomes minus 3, and the square root of negative sign becomes iota, and we apply these two separately on both of these two values, and we get this is 2 times 2 is 4, this is also 2 times 2 becomes 4. Finally, we have the other roots of the second equation are 2 plus minus 2 times of square root of 3 into iota. So these are the complex roots of the given equation. So in the second equation, we get these three roots of the given equation. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.